What stage are you at in your Terraform automation journey? In this video, I will walk you through the 4 stages of Terraform automation. We will discuss in detail each stage's attributes and how N0 can help you as your organization matures through these stages. I will also show you a demo of what a mature organization looks like at stage 4 using N0. So stay tuned till the end. Let's get started. Let's now go through the 4 stages of Terraform automation with N0. So our agenda, we're going to go through these 4 stages. Stage 1, basic automation with version control systems. Stage 2, infrastructure as code, specialized pipelines. And then stage 3, advanced Terraform orchestration. Finally, stage 4, we'll see self-service with governance. Starting off with stage 1, you want to integrate your version control system with Terraform. And something like this here, where some people use Atlantis. When a PR or a merge request is opened or updated, Atlantis automatically runs Terraform plan and posts the output as a comment on the PR. Then after reviewing the plan, if changes are approved, commenting Atlantis apply on the PR applies the changes and posts the results in Atlantis. And N0 really simplifies the Terraform automation process. With N0, you can create templates that are tied to your version control system, redeployment process, and Terraform plans on pull requests. So in N0, you can check these 2 boxes, redeploy on every push to the Git branch, and you can also run Terraform plan on pull requests targeting this branch, which will generate this speculative plan that you can review at the PR review meetings. Stage 2, as the organization matures a little bit more in their automation practices, they start to adopt specialized CI/CD pipelines that are specific to infrastructure as code. And these pipelines include additional steps such as linting, security scans, testing for Terraform, and you can also pass logic to another tool like a config management tool such as Ansible to continue your configuration to your resources as you need to. How can N0 help at this stage? N0 supports infrastructure as code specialized pipelines through custom flows, which I really like about N0 because now you don't have to worry about GitLab or GitHub Actions and create your own pipelines through another tool. It's all embedded within N0. And those custom flows allow you to run bash commands at various stages of the Terraform process, such as init, plan, apply, and output. And custom flows also allow you to install any kind of tool that you need, such as Ansible for configuration management. And this flexibility really ensures that all your necessary checks and configs are performed automatically, which enhances the reliability and security of your deployments. And here's an example from a previous blog post that I wrote, integrating Ansible with Terraform. You can see here under the Terraform output stage. After that stage, you can run a Terraform output and take the private key, store it in a particular file. You can change the permissions of the file. We can also take the output of Terraform and feed that into an inventory file in Ansible and get Ansible installed and go ahead and run Ansible playbook, which really enhances the automation that we can do with N0. Moving on to stage 3, and this is advanced Terraform orchestration. As organizations continue to mature, it's important to manage infrastructure as what we call micro-infrastructure, which involves breaking down large monolithic Terraform configs into smaller, loosely coupled ones. And this slide highlights the importance of managing infrastructure as micro-infrastructure, similar to what we do with microservices. Take a closer look at this whole concept of orchestrating micro-infrastructure. So we need a mechanism to actually orchestrate those micro-infrastructures and determine their dependencies. Also, determining dependencies involves identifying what order which resources should be created. Creating environments also that are specific to environment, function, and team. And what I mean by environment is dev, prod, QA, test. Function could be compute, could be database storage, and team could be a team name, team A, team B, or a business unit. And using workflows involves automating the creation and configuration of dependent resources using some sort of an orchestrator. And what you see here, and this is what we're going to do in our demo later, is that we've got env0 in this blue box, and we have a network project that the network team would have created. So this is under the ownership of the network team. And what they would do is create a VPC in AWS with subnets and gateways, and they're responsible through our back to do whatever they need to do. And any other team could probably only have read access into this project, but cannot make changes. And now for our purposes, we are going to build something called a workflow in env0 that allows us to create a Kubernetes cluster, in this case an EKS cluster, as you can see here, with an EKS template, and then deploy monitoring through Helm templates onto this cluster. So we're deploying Prometheus and Grafana. And all this will be packaged with env0's workflow, which basically says that every time we want to create a Kubernetes cluster, an EKS cluster, always stamp out these monitoring applications. It could be any number of applications that you want to have in all your clusters. And again, there's dependencies here, so you have to have the EKS cluster first, and then the Helm templates can run. env0's workflow will take care of that for us. And on top of that, we can leverage the outputs from the network projects, such as the VPC ID and also the subnet IDs. So we can grab that information from the existing project and feed it into our workflow. So how can env0 help? env0 uses the term environment for micro-infrastructure. And the way to orchestrate multiple environments with their dependencies is by using env0's workflows functionality that I just mentioned. We can manage your entire infrastructure with complex dependencies between environments and have a visual presentation of the complex deployments. So you can see an example of a screenshot here that I took where we got EKS, and after EKS we can create Prometheus and Grafana. So this is the dependency here in a nice presentation. And each environment can use a different infrastructure as code tool. For example, EKS is using Terraform, and Prometheus and Grafana are using Helm. And that's the beauty about env0. It's not just Terraform. You can have multiple frameworks such as Pulumi, such as Helm, Kubernetes, and OpenTofu, and much more. Let's move on to stage 4, and this is the final stage where organizations tend to want to arrive at, and that's self-service with governance. Governance is essential for successful Terraform automation, and to be able to reach that self-service stage, we really have to have security and compliance, cost management, and reliability. Let's start off with security and compliance. So again, to have a successful self-service model, we have to have security and compliance in place. And what this looks like is a producers and consumers model, where producers are well-versed engineers in Terraform. They're experts in Terraform, for example. It could be Terraform, could be something else like Pulumi. And then they can create sort of black boxes, let's say modules in Terraform's language. And consumers would take those modules and apply them to their infrastructure, what they need to build. Consumers don't need to be experts in the infrastructure as code technology, but they should be able to just use what producers are building. Then there's governance and policies that will, again, govern and put guardrails around what we can build. And then policy as code is really the engine that drives our policies. And we use Open Policy Agent, which is becoming a standard in the industry today. How can env0 help? So env0 supports policy as code, allowing you to automate policy enforcement and maintain compliance across your infrastructure. And it uses OPA, so OPA or OPA, Open Policy Agent. And you can define and enforce these policies in two places, at runtime and during deployments, ensuring that all your infrastructure changes adhere to your organization's standards. The second piece is really around cost control and how you can automate Terraform using cost control. And cost management is very important in governance. Tools like InfraCost help estimate the cost impact of your infrastructure as code changes. And really, InfraCost is the tool that env0 uses under the hood. You also want to properly tag your resources. That is essential for optimizing your costs. For example, some organizations I worked with implement bots that can scan environments and shut down resources based on tags. And manual tagging is pretty painful. So having an automated process is absolutely needed. And this is where env0 can come in and help. So env0 offers cost estimation, also budget notifications to keep an eye on your cost. It also offers the idea of automatic tagging, and this is a feature that env0 has open sourced with a project called TerraTag, where you can define, let's say, I want to put environment equals dev or prod, and it will go out and stamp out those tags across all the resources that you've added inside of your project, for example. Next up is reliability with auto drift detection and remediation. We want to be able to monitor our infrastructure changes and detect any config drift that is vital for maintaining reliability. And drift can occur for many different reasons, and detecting that and addressing it really quickly is absolutely important. So how can env0 help with that? env0 provides real-time monitoring and smart drift detection features that ensures that any config changes or drifts can be identified very quickly. We can automate the process of remediation depending on what kind of drift was detected. That's very important. And now let's jump into a demo of a mature organization and what that looks like using env0. Let's now go ahead and build our demo. And we have a project here that is called Networking AWS that we're assuming that the network team has already created a VPC for us and other requirements to get our networking ready to go. So we have a running environment here, and we see the outputs here. We got region, US East 1, we've got VPC ID, we've got our VPC private subnet IDs. And these are going to be important as we take these outputs from this project and feed them into another project that we're building. So if we go back to projects, we have a project that I've already created, and it's called Terraform Automation for a Mature Organization. So if you click on that, we don't have any environments just yet. So we're going to go ahead and set everything for this environment to get started. And what you'll see is that we have a few templates in this project. The first template is the Terraform automation template that's going to create an EKS cluster and then create Grafana and Prometheus inside of this cluster. So it orchestrates based on the dependencies. It will create first EKS and then the Helm charts. And if we go ahead and take a look at the settings of this template, we see that if it's of type workflow, we have a name for it, and it's tied to our version control system, this repo here, and it's under this workflow folder called Terraform. We have a few variables here. We have an InfraCost API key. We have an env0 Terra tag, custom tag of environment dev. And if you recall from the slides, the Terra tag project by env0 allows you to tag across all the resources that we're going to build with Terraform, so we don't have to do this manually. We're also using a soft fail for our Chekhov checks, so we can do scanning over our Terraform, and we're just going to soft fail. It will give us warnings, but it won't stop the actual run. And of course, we've tied this template to our project Terraform Automation for Mature Organization. So that's the first template. We have a second template here, which is EKS. So if you look at this one is a Terraform template, and you can see it's tied to our same version control system repo, but under the Terraform folder, Terraform/EKS. We have variables, don't care about too much at this point. And again, the project that we're tying it to is the same project. And if we go back to our templates, we have Grafana and Prometheus, which are Helm templates. So they are of type Helm. And for these ones, we're tying them to an actual Helm repository directly, the grafana.github Helm charts. And From a variables perspective, we don't really have much here. And also we have two projects that we've tied this template to. And finally, the last template here is Prometheus, and it's very similar to Grafana. The difference, of course, is the repo that we've tied it to. And variables are the same, and the projects are the same. Okay, so let's go back to our project here, and we can take a look at our settings. Credentials, you'll see that we've tied our AWS credentials, and we've tied our Kubernetes credentials as well for the name of the cluster that we're building, NF0 EKS cluster. And we have also cost credentials for AWS. In addition to that, we have our policies. So in here, we're going to see that we have two policies, policies main and policies remediation. They're also tied to the same repo. And if we go in here, you can see that we can tie them to any kind of version control system. We have GitHub here and our repo. Now we're going to take a deeper look at these policies and what they mean, but just know that we're setting everything here from the policies settings inside of our project. We also have notifications enabled in our Slack channel. And we have all kinds of teams have access to this project. I didn't really specify exactly what the teams do, but you can obviously, through RBAC, put some more control over that. All right, now let's go back to our project and let's create a new environment. So click Create New Environment, Template. And from here, we're going to use our Terraform automation. So go ahead and click Run Now. And from here, you'll see that we have drift detection enabled once an hour. And we have redeploy on every push to the Git branch, run PR plan on pull request targeting this branch. Destroy environment here is unlimited. You can, of course, say that you want to make sure that it destroys in a month, in an hour, in really whatever you need. So this is helpful if you are running this in a test environment and you want to make sure you don't forget your resources. You see the variables here are inherited from our template for the custom tags and the soft fail. We also want to go into the EKS portion and make sure that everything is set correctly. I need Terraform variables specifically for getting the VPC ID, the subnet IDs and region. So we're going to go ahead and add a variable, and this is important because we're going to use the environment output of another environment that's running, and we can go ahead and look for it here. If you recall, the networking AWS project and our environment that's running there, and the output name will start with VPC ID. The name of the variable that I use here is VPC ID, as simple as that. So that's the variable in Terraform that I'm using inside of the EKS template. So we're going to go add another environment output here, and this will become the private subnet IDs. And finally, the last one is the region. So we can also grab that from the networking project. And we are all set now for the EKS deployment. We can also go ahead and look at Prometheus. And for Prometheus, the release name, let's call it Prom, and the namespace we'll call monitoring. And that is good. You can see everything was good. And then Grafana, we're going to use Grafana for this one. And the namespace, we're also going to use monitoring. Okay, so that all looks good. So we're going back to the entire workflow. Now that we have everything all set up to go, we can go ahead and run this. This will build everything that we need with the proper order. So the EKS cluster will get built first, and then Prometheus and Grafana will get built in parallel. But then we can obviously go into the EKS deployment and look at the deployment logs. So I can see here we're going through the different steps. We've already run through the Terraform plan. And if you expand this, you can see we have 36 resources that are going to get created, all to do with EKS and the outputs that we expect out of this. And here we're running the Chekhov install. So you can see that we're installing Chekhov to run a scan, and the security scan actually ran, and you can see the results here. We have passed 116, failed checks 9, skip checks 0. And again, because we are just doing a soft fail, we just want to get an overview of the results of Chekhov. Later on, as we mature in our organization, we can have more of a strict policy to fail in case we do run into some of these issues and vulnerabilities. We have cost estimation that ran as well, and we can see that we're going to have a $476 per month cost, and everything is broken down here using infra cost. So you can see how much everything is going to cost. So it looks like EKS cluster $438. The node group is 38. The KMS going to cost us $1. And CloudWatch, minimal. So yeah, the majority is of course EKS and the resources that EKS is using. And then we have our approval policies, and you can see here, this is where OPA kicks in, and we have a couple of things that we have set here. If you look at the two policies that we have, the policies main that I just mentioned, and the output of that is that we are in a place of pending FinOps rule to require approval from cost approvals if cost estimation is greater than $15 per month. And since we are 470 something, of course, that's more than $15. So we're waiting for an approver that is allowed to do that. And we have, I'll show you later, the approval list is actually called the approvers team. I have a team called approvers team. Any members of this team are allowed to approve this. The second policy is policies remediation. And for this one, we're also pending asking for approval for any creations. So as you'll see later, when we talk about drift detection remediation, we have this rule in place in case we do incur some drift. We're going to allow any updates to the infrastructure to go through without needing approval. Whereas any creation and deletion, we're going to ask for approval just to make sure that any drift that happens is actually real drift and not something we intended to do. So with that, I can go ahead and click approve. And now we see the Terraform apply is in progress. So this will take its sweet time. Pause the video and we'll come back once this is complete. So our apply finished. As you can see, we have our outputs here, the cluster endpoint, cluster name, cluster security group ID, and region. Okay, also Terraform output. And we have a stage after the output, which is a custom flow that creates this monitoring namespace. As you can see here, we're looking at creating the region or creating a variable region from the Terraform output region, and same thing for the cluster name. And then what we're doing is we're looking at grabbing the kubeconfig for the AWS EKS cluster and creating this namespace, kubectl create namespace. All right. And this is just the output here of the Terraform output. And we can see we're updating the kubeconfig right here. That's the output, added the new context, creating the new namespace monitoring, and then namespace monitoring is created. So that all worked fine. And this has completed. If we go back to our environments and click back in the environment, you see EKS is done, and also Prometheus and Grafana has also completed. So if you go into Prometheus, you can see the different steps down to the Helm upgrade, which went on and created our Helm chart, as you can see here for Prometheus. And similarly, you can see the same thing happened for Grafana as well. Back down to the Helm upgrade, and that got created. We were able to build the EKS cluster and also create a namespace for monitoring and also put in our Prometheus and Grafana applications, and they're all running very well. Now let's talk about automatically detecting drift and then also automatically remediating And it's important to understand that we got to be careful when we want to automatically remediate, because sometimes you could do something outside of Terraform that will cause drift. And it could be that you've updated something that could have caused an outage earlier and you forgot to update this in Terraform. So we don't want an automation that will potentially cause the outage to happen again. So that's why we got to be careful, and we got to add a policy in place, which I'll show you in just a minute. But first of all, we need to have something enabled here, and that is scheduling. So if you go under your environment and workflow settings, we need to enable scheduling, and you can put this as a cron job. So something like this, and it will help you along like this. It will trigger every 2 hours to run our build. And the idea here is that we will continuously deploy, and this will enable this auto remediation. Now, the second piece is to apply an OPA policy that makes sure that we're only updating and not creating or destroying, for example. Now, if we go back to our environment, we see our next schedule is going to run in 1 hour. This is the time till our next deploy, because we're running every 2 hours on the hour. So if we go to our project settings and go to policies, notice that we have our policies. I have another policy under remediation. So if we take a look at this in Visual Studio Code, you'll see that we have this update only Rego policy under remediation under policies. And basically what this does, it looks at an approver's team. The first rule here, the pending, you can see that we're going to ask for approval for any resources that are creation or deletion, and with not any approver present. So the any resource with creation and with deletion, if we scroll down to the bottom, you'll see creation and deletion. We're really looking in the plan, and the resource changes of the plan under change.actions is delete or create. So if that's the case, then we're going to be pending and we'll wait for an approval. Otherwise, if it's an update and we have an approver present, then we're good to go. We don't need to be pending. We don't need to wait on anybody, and we're good to go. And once again, any approver present, as you see here, input.approvers of teams is under this cost approvers, which is a team inside of N0 that I have approvers underscore team. That's the team name. So anybody under this team will be able to go ahead and approve. Now let's go ahead and introduce drift. So what we'll do is we're going to go into our EKS cluster here in the AWS console, go to tags, and what we'll do is we go manage tags. Let's change our environment from dev to prod and click save changes. Now this will take a little bit of time, and what happens is N0 runs a drift detection every hour, and then that will detect that we've made changes. And since we're running our deployment every couple of hours, then that will get automatically picked up. And since this is an update on a tag, that should be done automatically without asking for approval. After some time, we see that we have drift that got detected in our environment. Instead of waiting for our next schedule to run here for our deployment, let's go ahead and manually click redeploy. Click run and go into EKS. And we can look at our deployment logs. And we see that we have Terraform plan already ran, and we have a change. And we are coming back to restore the environment from prod back to dev, because that's what we wanted in our Terraform configuration. We continue down here, we see that Chekhov is installed and we're running our security scan, which passed. Cost estimation, we see that we have no changes. It's the same amount that we expected. The approval policies have passed. Since we have specifically the one we're interested in is the automatically allow for any updates. We can see that, which is the policies remediation automatically allow for any updates, since we are just updating here. And we have our cost approvers is the approvers team. So that got deployed. Finally, here we can see the Terraform apply. And if we go back to our AWS console and let's go ahead and refresh here, you see that our environment is back to dev. So that really shows us how we can quickly automate this. And one more thing we can truly test this is let's go ahead and make a change in our Terraform configuration. And I have a S3 bucket that I'm going to add just for the sake of showing you drift. And let's assume that somebody goes out and creates this AWS S3 bucket or even deletes it. So this is just to simulate what would happen in case of a drift for something other than an update. In this case, it's a create. Let's go ahead and commit this. Create S3 bucket or drift test. And what this should do is trigger automatically a run for us in env0. So if I go back here and take a look at our environments, we see a run on already got started. And we'll just wait until we come to the approval policies, because this is where we should be asked to approve this before we continue. And here we go. We see that there's a Terraform plan. We have a create for the AWS S3 bucket. And down here under approval policies, we're waiting for approval. And we can see the final result of OPA is policy result pending, ask for approval for any creations. So let's go ahead and approve this. And we see that Terraform apply has successfully completed and the deployment is complete. And this really shows you how in a mature organization, we have self-service with governance, with policy as code, with OPA, with drift detection and remediation, and being careful of what exactly we're going to automate in terms of remediation. Finally, in this last section, I want to walk you through a couple of files. So here's our repo that we've been working through. The policies here is broken down into main and remediation. Remediation, we looked through this policy before. Cost policy is very similar. We have our cost of approver name. This is the team, approvers team. Cost limit, we put $15. And we have a pending in case the cost estimation, monthly cost difference is not equal to 0. And if the total monthly cost is greater than this cost limit of $15 and not any approver present, then we're going to issue this message. FinOps rule requires approval for cost approvers if cost estimation is greater than this $15 that we mentioned. We'll also issue a warning if we have the total monthly cost greater than 2 times the cost limit as well, which we have in our case $477. Then allowing here if any approver is present and the input approvers team's name is cost approvers. So if you're a member of this team, this will pass. And input cost estimation, total monthly cost, if it's less than this $15, then we're going to allow the policy automatically. These are our policies in this folder. Under this folder, Terraform, I have EKS and VPC. VPC is really the project that we saw earlier for creating the VPC with the VPC IDs and subnets and so on. So don't worry about that too much. EKS is the folder that we're using for the Terraform to build our EKS cluster. This is pretty straightforward with a module for EKS. What I want you to pay attention to is this env0.workflow.yaml. And this is really the orchestrator for our workflows, which allows us to create the EKS environment. You can see the name is EKS, the template name is EKS. Workspace, we give it the name EKS dev. And then we've got Prometheus and we've got Grafana. And you can see the dependency here needs EKS and needs EKS. We see the template name, workspace, and so on. And settings, environment removal strategy is destroy. So that's the workflow that we're using in this example. And if we go into the EKS folder once again, and if you see this env0.yaml, this is the custom flow, where here we're defining at the step or stage Terraform plan. Right after the Terraform plan, we're going to install checkoff, which we saw in the logs. And then we're going to run the checkoff security scan, as you see here. And we define here soft fail environment variable as soft fail in our example, so we don't stop the run. And then Terraform output stage. After Terraform output, this is where we're creating the monitoring namespace in here, and we saw this also in the logs. In this video, we explored the 4 stages of Terraform automation, detailing each phase's attributes and how N0 facilitated the transition as organizations mature. The stages covered from the bottom of the pyramid up are basic automation with version control systems, infrastructure as code with specialized pipelines, advanced Terraform orchestration with microinfrastructure, and self-service with governance. We also saw a demo of a mature organization at stage 4 using N0. I hope this guide helps you along your journey as you automate your Terraform environments, and I'll see you in the next video.